Alright, so let's take a look at this video. This is a video doing the derivative of tangent, cotangent, secant, and cosecant. I've got a video, another one, that's about a little over 20 minutes long. It's on derivative of sine and cosine, so you can check that out. But you see I've got the formulas here. You've got to memorize them. Okay. Now you notice I have this tangent of u, taking the derivative of tangent u with respect to x. Well, I'll explain that in just a second. But just remember that when you're taking the derivative of, let's say you just have tangent x with respect to x, that's secant squared x, and the derivative of cotangent x with respect to x is negative cosecant squared x, and the derivative of secant x with respect to x is equal to secant x tangent x, and then the derivative of cosecant x with respect to x is equal to negative cosecant x cotangent x. Okay, so that's just if you're these are the formulas that, if when you're taking just the derivative of tangent x, cotangent x, secant x, or cosecant x. But what I have over here, this u, u is like say if you have a function in there other than x, say like maybe you have an x squared or a x minus 3. If you're taking you got tangent of x minus 3, or something like that. Okay, so what you're doing, it's the same thing as this over here. It's just the derivative of tangent u is secant squared u. See, just like the derivative of tangent x is secant squared x. But then what you have to do is you have to multiply by the derivative of u. Okay, you've got to multiply by the derivative of what you're taking the tangent of. And look, that's the same thing over here. If we apply this property, look, the derivative of tangent x is secant squared x, and then if we do times the derivative of this x value, well, what's the derivative of x? It's 1. So 1 times secant squared x is just secant squared x. So it's, you're doing the same thing. It's just that we know the derivative of x is just 1. Okay. All right. So let's take a look at the problems. Here's the problems that I'll be working. I've got 8 examples. I think the video on sine and cosine, I've got 9 examples. So check that one out too. But let's go ahead and get started. All right. So for the first one, we want to do the derivative of y equals 2 tangent 8x. So we'll get y prime is equal to, okay, so that's 2 times, and then the derivative of tangent, remember, that's secant squared, okay. Then it's times the derivative of what you're taking the tangent of. So the derivative of 8x is 8, and so I get y prime is equal to 16 secant squared 8x, and this would be your answer. Okay. All right, so let's look at this one. Here we've got y equals 3 secant squared 4x. Now I'm going to go ahead and rewrite this one, and what you've got to understand here is this secant squared 4x. When I rewrite it, I'm not taking the derivative yet, I'm just rewriting this. Y equals 3 secant 4x, all of that squared. Okay, that's what this means here, this squared here. It's all of this squared. We just don't put it in parentheses and square it. We just, instead of writing it like this, we just put the exponent here. Okay, so now how do we take the derivative of this? Well, this is chain rule. This is similar to like when you had something like this, say x squared plus 3 to the 3rd power. Okay, so if you take the derivative of this, you would use the chain rule. So the 3 would come down, x squared plus 3, subtract 1 from the exponent, and then times the derivative of what's inside the parentheses. So what's the derivative of this? 2x. And then you would get 6x times x squared plus 3 squared. And that's the same thing we're going to do here. We're going to apply the chain rule. All right. So let's look at this. So I've got y prime, the 2 comes down, that's 6, times secant 4x, subtract 1 from the exponent, which is just 1. Okay. And then it's what? Times the derivative of what's in here, times the derivative of what's inside the parentheses here. So what's the derivative of secant? Well, remember the derivative of secant is secant tangent. Okay. So the derivative of secant 4x is secant 4x tangent 4x times the derivative of what I'm taking the secant of, so times 4. And so that's going to give me y prime, 4 times 6, that's 24. And then look at this, I've got secant 4x times secant 4x, that's secant squared 4x times tangent 4x. And this is your answer. Okay. Alright, so let's take a look at the next one. Alright, so I'm not going to rewrite this one like I did this one here, but just remember this cosecant cubed 2x, all that means is cosecant 2x, all of that cubed. Okay, I guess what we could do here is we might could come over here and just write it cosecant 2x, all of that cubed. Remember, that's what that looks like. Okay. So here we've got y prime. Now look at this, we've got x times cosecant cubed. This is the product rule. Do you remember the product rule? Well, remember the derivative of f times g, if we have two functions multiplied together, it's the derivative of the first function times the second function plus the derivative of the second function times the first function. Okay, so we got to apply the product rule here. Alright, so let's go ahead and get started. So the derivative of the first function, so the derivative of x is 1, times the second function, so that's cosecant cubed 2x. Okay, so this is the derivative of the first function times the second function plus, and now I got to do the derivative of the second function. So this is what? Chain rule. Remember, it's this. So the 3 comes down, so 3 cosecant squared, subtract 1. See, the 3 comes down, subtract 1, so that's where the 2 comes from. 2x, okay, so that comes down, subtract 1, and then it's times the derivative of what's inside the parentheses here. So what's the derivative of cosecant? Well, that's negative cosecant 2x. Whoop, I was fixing to write tangent. Cotangent 2x. Okay. Alright, so remember, the 3 came down, subtract 1 from the exponent, then times the derivative of what's inside the parentheses. So that's negative cosecant 2x, cotangent 2x, times the derivative of what you're taking the cosecant of, so times 2. Okay, so this, all of this, that's the derivative of the second function times the first function. Okay, and now let's see what we can do with this. Let's see, that's cosecant cubed 2x, and let's see, that is going to be what, negative 6x cosecant squared 2x, no, cosecant cubed, see, cosecant squared times cosecant, that's going to be cosecant cubed, cotangent 2x. And then, I mean, I guess you could leave it like that. If you wanted to do a little more to it, you could factor out a cosecant cubed 2x, and that would leave you with 1 minus 6x cotangent 2x. I think this looks a little neater, a little better than this line up here, so yeah, I'd go ahead and factor that cosecant cubed out. Alright, so let's look at the next one. Alright, so I've got tangent 2x plus secant 2x, and then all of that's in parentheses cubed, so we've got chain rule here. Alright, so that's going to give me y prime equals, okay, so the 3 comes down in front, so that's 3, and then that's going to be tangent 2x plus secant 2x, and then subtract 1 from the exponent, okay, and then times the derivative of what's inside the parentheses, so times the derivative of this. Alright, so the derivative of tangent, well, let's see, derivative of tangent, remember that's secant squared 2x times the derivative of what you're taking the tangent of, so times 2, plus the derivative of secant 2x. Remember, derivative of secant, that's going to be secant 2x tangent 2x times the derivative of what you're taking the secant of, so times 2. Alright, so I don't know, let's see what we can do with this. We can factor a secant out, you see that, and we can factor the 2 out, so let's do that. So I get y prime, so if I factor the 2 out, that's going to make this a 6, and that's going to be, well, hang on, and then let's factor out a secant, so that's going to be secant 2x, okay, times, and then I've got this tangent 2x plus secant 2x squared. I wrote this down. Okay, so remember I factored out the secant, had a common factor of secant, and I factored out the 2. Alright, so that's going to leave me with what? A secant 2x, factored out a secant, and I have a secant squared, so that'll leave me with secant 2x, and then plus tangent 2x. And then look at this, that's y prime is 6 secant 2x, and then look at this. You see this and this is to the first power, right? So remember, when you're multiplying and see this and this are like bases, you add the exponents. So that's going to be times tangent 2x plus secant 2x cubed, because the 2 plus the 1 will give me cubed, and so this will be my answer. Alright, how about the next one? I've got y equals 2x tangent x squared. Alright, so we've got the product rule here. So remember, for the product rule, it's the derivative of the first function, so the derivative of sine is cosine, times the derivative of what we're taking the sine of, so times 2. So this is the derivative of the first function, and then times the second function, so times tangent x squared, plus the derivative of the second function. Okay, so remember, the derivative of tangent, that's secant squared x squared, times the derivative of what you're taking the tangent of, so times 2x. So this is the derivative of the second function, and then times the first function. And then, I don't know, let's see what we can do to maybe, I don't know if there's much we can do to simplify it. I guess about the only thing I could do here is factor out a 2. So that really is not going to make much difference, but we'll go ahead and do it. So that's cosine 2x tangent x squared plus, and then there's that x, we'll bring that out in the front, and we'll write the sine first instead of the secant, and it's not a big deal. You could write secant squared first, it doesn't matter. And so I'm not going to really think about this too much about simplifying, so we'll just leave it like that. So yeah, I don't think there's really much anything you can do anyway. Alright, so now let's look at this one. Here we have quotient rule. Okay, we just got finished doing some with product rule. What about the quotient rule? Well, remember the quotient rule. If you take the derivative of a quotient, so I've got the derivative of f over g. Well, remember that's the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all that over the denominator squared. Alright, so let's see what we get here. So I've got y prime. Alright, so it's the derivative of the numerator, so I'm taking the derivative of this cosine 4x, so that's going to be 2, and the derivative of cosine is, remember that's negative sine. That's in the other video. Okay, so if you want to look at a video on derivative of sine and cosine, check that video out. Alright, so the derivative of cosine is negative sine, and then times the derivative of what we're taking the cosine of, so times 4. So this is the derivative of the numerator times the denominator, so times 1 plus cotangent 3x. So the derivative of the numerator times the denominator minus the derivative of the denominator. Alright, so let's take the derivative of the denominator. Well, the derivative of 1 is 0, and then the derivative of cotangent, well, remember derivative of cotangent is negative cosecant squared times the derivative of what you're taking the cotangent of. So times the derivative of 3x is 3. Alright, so this is the derivative of the denominator and then times the numerator. So times 2 cosine 4x. And then this is all over the denominator squared. And now let's see, simplifying this thing. I don't think there's a whole lot you can do. Let's see, I've got the 2 and the 4 and the negative here, so that's going to give me negative 8 sine 4x times 1 plus cotangent 3x. And let's see, the negative and negative, that's going to be a plus, and then I've got 3 times 2, that's 6, and that's going to be cosine. I'm going to write the cosine first instead of the cosecant. It's not a big deal. Cosecant squared 3x, and this is all over 1 plus cotangent 3x, all of that squared. And then as far as what else you can do with this, I don't think really much. I guess if you wanted to, you could take this and distribute it to the 1 and the cotangent, but I mean that's not really necessary. I'd just leave it like this. I think that would be good enough. Alright, so let's look at problem 7. Alright, we got y equals cotangent squared 1 minus x squared. Alright, so remember this, I don't know what happened there. Alright, so look at this. Remember, cotangent squared, that's cotangent, I'm sorry, I wrote cosine. That's cotangent 1 minus x squared, and then all of that squared. This 2 here, that's what it means, all of it squared. Okay, so we've got chain rule. So the 2 comes down. See, the 2 comes down, so I got y prime is 2 cotangent 1 minus x squared. Subtract 1 from the exponent, so if I subtract 1 from the 2, that leaves me with a 1, so that's just cotangent. And then it's what? Times the derivative of what's in parentheses. See? Times the derivative of what's inside the parentheses. What you need to try to do is get to the point where when you see this, you can picture this in your head. And if you can't, just write this down over here to the side like this, and so you can see it. Okay? Alright, so now I've got to take the derivative of this. So what's the derivative of cotangent? Well, derivative of cotangent is what? Negative cosecant squared 1 minus x squared, right? So the derivative of cotangent is negative cosecant squared times the derivative of what you're taking the cotangent of. So the derivative of 1 minus x squared is negative 2x. Okay? Alright, so now I've got y prime is, let's see, the negative and negative is positive. 2x times 2, that's 4x. And that's going to be cotangent 1 minus x squared times cosecant squared 1 minus x squared. And there's your answer. Alright, so now we finally got to the last problem. And hopefully all this is helping you if you're still with me in the video. Alright, so here we've got quotient rule. So remember, quotient rule, that's what? That's the derivative of the numerator. So the derivative of cosecant is what? Negative cosecant cotangent. Okay, so there's the derivative of the numerator times the denominator minus the derivative of the denominator, which is 1, times the numerator all over the denominator squared. And then let's see what we can do. So y prime, that is going to be, well, let's do this in a couple of steps. Negative cosecant, negative x cosecant x cotangent x minus cosecant x over x squared. And then I guess, you don't really have to, but this cosecant here, you could actually factor that out. Might make it look a little better. So, and let's factor out a negative cosecant. So negative cosecant x times, and that's going to leave me with x cotangent x plus 1. Remember, factored out a negative, so the signs will change, and that's over x squared. And there's your answer. Alright, so yeah, this was kind of a long video, but hopefully it helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching.